Good morning, and it is April 1st. Welcome to our number corner. And the first of the month was always such an exciting day in our classroom because our class was so good at number corner. They were so smart when it came to the patterns. So whenever I had a new calendar set up, I know how excited I was. I think the students were excited, maybe not as excited as me, but we were always so excited. It was the first of the month. Let's see what our patterns are going to look like. What are we going to learn? So it's not the same this way, but I hope you're watching these videos and I hope you're a little bit excited because I know I am. This month, we're going to talk about fractions, and shapes. Now, let me turn my first card. I'll show you the calendar marker. Then I'm going to show you some of the worksheets you have to do today just to review, give you a couple tips on them. And that'll be that. I'll try to make these as quick as possible. I'm not going to do everything. Okay, so what do we notice? What shape do we have there? It has how many sides? 4. Are the sides all equal? Yes. Is it a quadrilateral? Yes. Are the angles, box angles? Yes. We know it's a square. Is a square 2-dimensional or 3-dimensional? 2-dimensional. Why is it 2-dimensional? Because it's flat. Oh, you are all so smart. So we have our square. And you may say, okay, Mr. K, I know about that. Now we're talking fractions. Let's see, and we did this before too. If you have a square and you need to cut it into equal parts, because remember, fractions are when you take a whole, and I'm going to try to show you this up close, and you cut it into equal parts. That is one way, it's not that equal, but pretend it is, that we can have a fraction. Another way you can have a fraction is if you have a set and you are given an equal part of a set. So we had 2 squares and I get 1 half of your squares. Those are the 2 ways we can have a fraction. A whole cut into equal parts. You're going to hear me say that a million times throughout the month. A million times. But right now, we're going to focus on taking the whole and cutting it into equal parts. Because remember, if we have our square and we cut it into parts like that, even though a square is cut into 2 pieces, that doesn't mean it's 1/2. That's not 1/2. I should put a big X. No. It has to be equal parts. It has to be equal parts. All right. So, and we tried this in the classroom, so this is a little bit of a review. When you have the square, this is a square, and I folded it to cut it into 2 equal parts. Would you agree with me? 1/2, 1/2. We agree? You can fold it another way. 1/2, 1/2. Do you agree? Is it a square? Are the parts equal? Is it cut into 2 equal parts? You betcha. Now, this is one of the most difficult things for students to understand with fractions, and adults too. Because fractions can be 2 rectangles from a square. They could be 2 triangles. They could be big. They can be small. It's really hard to grasp how 1/2 can be half of a set of 100, or a half could be 1/2 of a pizza. One is a circle. One is a set. They're both 1/2. Think about how tough that is to really wrap your mind around. That's what we're going to talk about this month. That's what we're going to be practicing. So I have a half here and a half here. They're both 1/2. They are both the same size square. They're both cut into equal parts. Which square has bigger halves? This is a question you will see on every single math assessment. They will take a square that is the same size. They'll cut it diagonally like Mother used to, and they'll cut it up and down. And then they'll say, which square has bigger halves? Some students will say, but the triangle one, because that's why Mom does it. Some of them will say, oh, because they did it up and down, and rectangles are bigger than triangles. Both of those are wrong. You have to say they are equal, because remember, they were the same size squares, and if you take something and cut it into equal parts, it doesn't matter if you cut it diagonally. It doesn't matter if you cut it up and down. You still have equal halves because you started with the same size square. Is that making some sense? Now, how could we take our halves and make it into fourths? Let's show you. That's one way to do it. Now I got my triangle. A square is a special shape. Boo, 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 boo. Oh, I think I did this one. I did this one wrong. See, look what I did. I'm rushing. I wanted to show you the ways that we can do this. So, pretend that this is 1, 2, 3, 4. 4 equal parts of the square. That means each part is what fraction? 4 equal parts of the square. That means each part is what fraction? 4 equal parts of the square. That means each part is what fraction? 1/4. And I've been saying equal parts. Now, there's a word we use in geometry for equal. So we usually use like equal in algebra with numbers. In geometry, we use this other word. And I challenge you to think back because I really hope you remember it. What word do we use in geometry when we say something is equal? Like equal shapes, they are blank shapes. Equal parts of a square, they are congruent parts. So you'll be hearing me say congruent. You'll be hearing me talk a lot about fractions. So we showed you how we can take a square, we can fold it into fourths this way with triangles. We can fold it into fourths this way. Each spot is a square. Or we can fold it into fourths this way where each fourth is a rectangle. They are all the same size fraction because we started with the same size square. I hope that's making some sense. And then lastly, if I write, so we have 1/4. If we take each part that I folded it into and put them all back together, what do we get? If I took each part that I folded it into and added them all back together, what would we possibly get? And remember, the top number of a fraction is a numerator. Bottom number is the denominator. That's how many parts it's cut into. The top number is how many parts that you have. So if you added 1/4 plus 1/4 plus 1/4 plus 1/4, and remember, these are all 1/4 because they are congruent parts of the whole, how many would you get if you added 1/4 plus 1/4 plus 1/4 plus 1/4? You would get 1/2, or another way of saying that is 4/4. You would have 4/4, of course, or 4/4 is the same as 1/2. And don't worry, I go quick. We do this every single day. So you'll just hear me repeat a lot of stuff, and I'm kind of throwing a lot at you, and I'll try to make it better as I go. So that was our first calendar marker. We have just begun. There's so much more we're going to do with that. Days in school. Ready? And this is important because it'll be part of your sheet that you have to do. So we've been at school for 128 days. I'm breaking it into tens, hundreds, and ones, such as that. Now you will need to graph the days in school. So you'll have to color the day's number on the 200 grids. See these grids? These are called hundreds grids. And notice the thick lines going through. What are the hundreds grids cut into? We were just doing it. They are cut into fourths. So each box with those thick lines is actually 25. Now, we've been at school for 128 days, so let me tell you, you should color in one of the 100 grids right away. You don't need to count boxes. You know it's been over 100, so you know you got to fill one in all the way. So just color one of the 100 grids in, because remember, there are 100 tiny little boxes in each of those grids. Then you can think about our tens and our ones. You could even think about our quarters. So 128, you color one in. Maybe you could think about the quarters because you know a quarter of 100 is 25. Or maybe you're just going to color straight up and down the rows of 10. Either way, you need to color in 128 boxes. But don't count them out one by one because that would be crazy. We should know how to do it a little bit quicker. Next, you're going to just be doing simple addition and subtraction. This is to practice your math facts. Then at the bottom, they have equivalent expressions. Are they equivalent or are they not? So 3 plus 4 is the same as 8. Is that true? No. Or these are equations, not expressions. That is not true, so you would circle false. I think you'll do really well on that. So thanks for watching Number Corner. Tune in tomorrow when we talk more about our shapes, and have a great day. Stop this every time.